Hi, I'm Johannes Bechberger. I'm giving a talk, as you heard, on unleashing the power of open source Java profiles. And yeah, without further ado, I want to start. You probably all know the situation when you are at like a community event and you're helping to organize it, and people ask you like, "Hey, Johannes, aren't you a software developer? Aren't you a software engineer? Couldn't you just write us a web application?" And that's what I did. That's what happened to me because like last year or year before, there was the Corona times, and we wanted to organize a small conference where people then could ask like questions online and answer also to a quiz. And the quiz would have questions like how old was the universe, and people could give like an estimate in and could win a small prize. And they were like, "Hey, aren't you a computer scientist?" And I was like, "Yes." I tried to do a PhD at the time, and I was like, "That's why I tried to do a PhD, to develop small Java applications, small Java applications." So anyways, that's what I did. And this application was quite simple. I had a client regularly polling the server and asking, "Hey, is there a question? And if yes, give it to me." And then I have an admin interface where the admin can set a question. And I thought like, hey, the server could be just simple, storing all the information in JSON database, like in JSON file, and all the time just reading in out of this file, because the file system takes care of the synchronization. It was like, yeah, we probably only have like 90 participants in this quiz, so it should probably work. But because I was like, with Donald Knuth, pretty much optimization is the root of all evil. And so the event came, and you might have already guessed it, what happened. Of course, the server was overwhelmed. So it wasn't great. So I was sitting there. So we were recording at a central location still, but we were sitting there all the time, restarting my Java server to probably get it running again. And this was kind of embarrassing, but yeah, it told me that I probably didn't read the whole quote of Don Knuth, because he wrote, actually, we should forget about the small efficiencies, say about 97% of the time. Pre-match optimization is the root of all evil. And he further wrote, yet we should not pass up our critical opportunities in the critical 3%. A good programmer will not be lost into complacency by such reasoning. It will be wise to look carefully at the critical code, but only after it has been identified. And that's where profiles come to the rescue. When I tell people on the street, or like friends that I have that aren't like computer scientists, about what I'm doing, that I'm profiling, they're like, aren't you someone like Sherlock Holmes, solving crime scenes and seeing who the murder was? I'm like, probably yes, because I'm essentially solving performance crimes. And in my case, in this small quiz application, I also know who the murder was. I was the murder. I did it wrong. I could look into Git blame and see I was the only author there. And then I could fix it. And one of the main core visualizations of that we use in the profiling space are flame graphs. So on the top, you see the pseudocode of my application, my server, and on the bottom, you see a flame graph building up. And the idea of the flame graph is that the width of the bars represents the amount of time spent in each method. Of course, well, you see then in relation to the calling method. So for example, here, the main method takes like all the time because it's like the main method. It does some setup, like getting probably seeing whether the port is usable and setting up all the infrastructure, but most of the time is spent in the server loop. And that's also reflected in the flame graphs below, because server loop takes up most of the width of the main bar. And then of course, what the server loop does, it usually just handles its question requests, because the admin requests are so few that they don't really matter here performance-wise. So essentially what it does, it checks like, hey, get a new request. And then if it is a question request, then it calls handle question request. And this handles it. And what this method does, it ask, is the current question enabled? And if yes, emit the current question as a JSON. And as you might have hopefully guessed it, of course, most of the time is spent in post-JSON. Yeah. That wasn't great, and that was the reason why it went, why the server was overwhelmed, and you see it here quite clearly. And to quote Mario Fusco, I love frame graphs. When you do something stupid, it punches you in your face, and it's impossible not to see it. And yeah, that's essentially what we see here. It's like parse JSON. It was probably not a good idea to store all the data just in a JSON file and reread it all the time. And then after the event, I got back and I rewrote the database part, like the storing part, and then just used the SQLite database, because after all, we're only having like 90 participants, so I don't need a full-blown database like Postgres. But it turned out that was much faster, and now the application works good under stress. It can handle even hundreds of users. The main problem is Corona is over, hopefully. So we can't use it anymore. But that's fine. It gave me a good... it's an interesting demo to show you that profiling is really important. And profiling belongs to your toolbox of techniques like debugging does and like testing does. Because when you have like a problem, you might do some profiling, but to do proper profiling, you also have to have tests, because usually you have to reproduce the situation to profile it properly and to get in to have ended to get in that knowledge. And so it belongs to your toolbox, and you should learn these techniques. So who am I that I talk to you about profiling? I'm Johannes Bechberger. I'm quite often talking about profiles and nowadays also debuggers in the world, as you see on my image. That's me at JCON London this year. I work at the Submachine team. It's one of the many cool open source projects at SAP. And Submachine, we're a small team, like with 15 people. We're working at the OpenJDK. So I'm an active OpenJDK contributor working on making profiling easier for everyone. And we're the third biggest contributor to this project. And when I'm working, for example, on profiling UIs. I'm working on the profiles themselves, and I'm also currently trying to get a new profiling API into the OpenJDK. That's a lot of work, but that's essentially what I'm doing. And of course, I'm giving talks at conference here. So enough of me. I hope this works in a chat setting. It's actually my first online conference that I ever did. So yay. Who of you used the profiler? Can you maybe just send an upwards thumbs up or thumbs down if you haven't used it in the chat? I hope I can see it then. I can't, here's the chat. Okay, okay, that's okay, cool. I'm trying to, okay. Yeah, cool. Oh, that's cool. That's interesting. Yeah, a few of you use it. And when I go to conferences, I also see that it's like most of them nowadays use it, and most of you nowadays use it, especially because it's like become more and more important, because we're developing more and more applications that run on servers, where we can see a correlation between like our performance and runtime and the costs, because we're like usually built in the cloud by the CPU minute. And so it's really important, and it's great that in the last couple of years, profiling got more important and people got more invested in it. And for those of you who haven't used profiles and who might have wondered what profiling is, you probably glanced some in the beginning, but to quote to quote the Hacker's Dictionary, maybe the older folks out there have this book at home. I don't have, but I found the quote from it on the topic of profiling, and it tells you that a profile, so the thing that we're creating during profiling, is a report on the amounts of time spent in each routine of a program used to identify and tune away the hotspots in it. So of course there are different profiles. So there's not just one. It would be cool if we had like one tool that solves everything, but there are different profiles and especially different techniques to build a profile. The first technique is quite simply the instrumenting profiler. So the idea is we insert instructions into code automatically. So what we do, consider we have our server loop method, and what we do when we do it like simple performance testing by hand, we will probably like get the time, maybe the time in milliseconds or nanoseconds at the start of the method, and then print at the end like, hey, server loop took this amount of time. And that's quite cool. It works. But the problem is it's quite cumbersome. We can automate this, of course. So on class load, so when the JVM first loads a class, we insert calls to our logging mechanism that essentially logs when a method is entered and exited, and then processes this data further. And that's cool because we get information on all instrumented methods, and we get the exact timings. The main problem is that in this case, our profile code isn't our production code. So this isn't with production code, I mean like the code that's actually in the end running, because we inserted, of course, new instructions, and this might hamper the JIT and also might hamper like the garbage collection, and might have adverse effects here. So this is where sampling profiles come in. So the main idea is that we're regularly asking the JVM like every 10 to 20 milliseconds, hey, what are you currently executing? So give me the stack trace. So the stack trace that you get from exceptions. Essentially, that's what we're asking the JVM every 10 to 20 milliseconds. And the cool thing, of course, with this is that the profile code is now the production code, because we're asking the JVM essentially from the outside, from not within our application, like, hey, please give me the things that you're currently working on. And so we get an approximation, but that's usually good enough. But this also means that like when you see that the profile tells you like, hey, this method, you spent like 10 milliseconds in this method, or you spent like a minute in this method, it's also just an approximation, because we're just asking to JVM at predefined points in time, but it's usually enough because we only care about larger methods anyway, because if a method is never hit during our sampling and we sample every 10 milliseconds, then we probably won't care about this method that much. So these sampling profiles approximated, and they're quite easy to write. So profiles aren't rocket science. And that's to keep in mind, as well as debuggers aren't rocket science, profiles aren't too. And so I thought like, hey, I know what profiles are, I know what the APIs are, so I thought like, hey, I could write my own, and I wrote a blog post and people liked it. So I'm giving you a short glance on how like a profile works, so maybe you can understand what a profile does and what its pros and cons are. So we develop, usual profiles are developed as agents, so as programs attached to your JVM at runtime. So we have a main method that takes care of like all the option processing, because profiles have, of course, options, for example, the interval duration. And then this starts our profile, and what the profile does, it takes a sample, it sleeps, takes a sample, it sleeps, and so on. And then it stores it back into a store, and then in some form or another, and then it often gives us a flame prof, because that's quite a useful visualization here. And flame graphs would be definitely great, but what we essentially get is we get different stack traces. because that's what we're doing when we're sampling. We're asking the JVM widely, so what are you doing for every thread? So consider now we have here the stack trace. So we have the stack trace where on the bottom is like main, then develop, and then question request, then count question, then parse JSON. And so we take this and then we create a tree, because like trees are great. Every computer scientist likes them because we can essentially have a tree that consists of these call nodes. So we have the main method. We denote with the small numbers how many times we hit the specific node. And so this called the server loop, this called tender question request, this called current question, this called parse JSON. And then back again, we possibly have the same stack trace again. Then we just get to the main method and see like, hey, the main node, oh, I already have it, cool. Then increment its hit value. Then we already have a server loop child, increment its hit value, and so on. Thereby we're increasing the numbers of all and storing this information. And then we have a new stack trace here. Parse JSON is missing, so of course parse JSON isn't incremented, but all the other nodes we already have them, so their number is incremented. And we have here the top two frames are changed, the top two methods, and so here at tender question request we see a new node, this question enable node, and so we're adding it here. And the idea essentially here is that we remove all the time information. So before we had like all this timing information of, hey, the stack trace occurred there and there, but when we're only interested in flame graphs, we can remove this information and thereby reduce the size of the collected data. Usually that's not done in practice, because we have cases where we want to specifically know when something happened, but it's a good way to think about how flame graphs are created, because that's essentially how we turn a collection of stack traces into flame graphs. So with here we know that like the main method is hit 4 times, so we have the large bar divided into 4 pieces. So loop also for hello question request or count question 3, so it gets bar 3 wide. Important is like that the ordering and also the color is usually not defined, and that's up to the individual tool. Here in my case, it's red because it's easier to make a presentation with, but most tools would either like have like semantic values for the colors to tell you that some methods are inlined or so, or they have just like variations of red to make them easily distinguishable. As you see here, that's like the small profiler that creates like the flame graph, but the actual flame graph generation from this call tree they showed you is done in my example using the power of D3 flame graph, which is like a JavaScript library. And that's essentially how you could write a profile. And the thing is, I put it out there. I wrote a blog post. It's MIT licensed, so you can take a look. And if you're interested more in this, there's even a talk at DevOps where the YouTube video is currently online, where you can look into, where I gave a whole talk about this. But so I put it online, my code, and then I gave a talk in Milan. And then someone told me like, hey, I can't use a profiler. I can't attach a different profiler at my company. So, hey, I could use your profiler embedded directly into my application, and then we're getting some profiles. So it was quite interesting. I didn't plan for it, but keep this in mind when you're developing open source and publishing it. Of course, people can use it for different things. So and can hack around and can view it. But in reality, we're of course not writing our own profiles. It would be cool, and there's some people out there that can do it, but in reality, we're using like sampling profiles, and specifically, we're using 3 different ones. They're like the most common. They can be divided into external and built-in. Like the external ones are external to the JVM and can work with different JVMs, and the built-in are like built into each Java virtual machine. So with the external ones, we have synchronous and asynchronous ones. Synchronous ones ask like the JVM, hey, please give me the flame chart, give me the stack trace if you're ready. So the JVM is ready at, for example, at returns of methods or jumps back in a loop. So when it's at the end of a loop where the instant jumps back and that method calls. And the cool thing is it's slightly safer, but the main problem here is that we of course have inaccuracy because we're only getting the stack traces at certain events. But they're quite commonly used according to some polls. Many people still use it. It's one of the most popular ones. It's Visual VM. And it was also like built into NetBeans. And that's actually the first profile that I ever used. It came out in 2010. So just around the time that I learned Java. So you now know how young I am. But essentially, we then have also the async ones where we ask the JVM and tell like, please give it me now and just now. And that's slightly less safe, but the advantage is that we don't have bias in it. So Sun developed it in 1991, the so-called fault analyzer, like a performance tool. And then in 2002, they added a call called async call trace, where you can asynchronously get like your stack trace, but they removed it 3 months later. And it's still in there. And then in 2007, people started using it for their own Java profiles. And in 2016, Andre Pangin started working on async profile, and that's like one of the most common open source profiles out there. And they show later how to work with them. Then there's of course building profiles, and one of them is the JDK flight recorder. That's like the prominent one and like the only one implemented into the OpenJDK. It started out in 2012 and was open sourced in 2018 together with a front end called JK Mission Control, which is like the leading open source profiling front end out there. And most other tools, like most profilers out there, for example, your application performance monitors from Elasticsearch, from and others are based on both async profile, many just copy it in, and on the data from the JDK flight recorder short JFR. Before telling you how to work with them, I'll have to tell you that you shouldn't blindly trust them. So the main problem is you write your own applications, and I know it from people in other industries. So like they're doing like, for example, in the realm of app development, they're like, I'm not trying, I'm not like, I don't like to use my own app because I know how many corners we cut. And that's essentially, that's how it is here. So don't trust your profile too much. It's like the same with every applications. It could have had more tests. It could have had more checks in it. The software could be documented better than everything. So please don't trust them. And I gave this talk also at JavaZone Oslo this year, and I was near the Munich Museum. So sometimes here when I'm doing profiling, it feels like I'm screaming into the void. They're great. It's only bad in corner cases, but still be aware of them. One of the main problems is that we have async get call trace out there, and there aren't that many tests in the OpenJDK. So there's only one single test currently in there, which isn't that great for an API where many people depend on for the profiling. But that's my work, so that's what I'm doing, and what I'm doing when I'm not giving a talk. I'm sitting on my Linux PC, creating a new profiling API and hoping to make this profiling world a bit better. So take profiles with a grain of salt. That's really important. And don't trust them blindly. As well, you shouldn't with every technology. You shouldn't trust it blindly. It's the same with ChatGPT nowadays. I asked it like, hey, who wrote this blog? And it was my blog. And it told me like, it's written by some folk there, and I didn't know why it hallucinated of it, and it was quite funny to use like these engines. But essentially, with profiles, it's not as bad, but still, take the profiles with a grain of salt. Many people are working to make them better, but so what helps me when I'm doing some profiling, to have like to be like in this profiling loop, and it starts with a model. So I start with a rough mental model of my application. For example, in my application, in the beginning with my server and my client, I know the basic structure of this application and I know the basic components. And I can then formulate using this in this model a hypothesis. For example, my hypothesis was that storing data solely in a JSON file and reading it all the time has probably a performance impact. And also probably not the best performance impact, so it's making it worse. And then if I can't formulate my hypothesis with the words of my model, inside my model, I have to update the model. And then when I have a working hypothesis, I can go to evaluation. So I can write a stress test. I can then evaluate and I can profile and see, yeah, it's really a problem. I can see in the flame graph, it's not great. Parsing JSON all the time it has a bad impact. And then of course, when I get new information on my hypothesis, I can refine it. And also when I learn more about like my model, when my mental model of my system improves by profiling, because that's also we're seeing like which method called which, we're seeing the larger components during profiling, then I can update my mental model. And so it's essentially a loop. And I just stole it from like the life sciences where they're doing the same, but I think it's really applicable for profiling. And the cool thing is then that when you have some inconsistencies, it's sometimes that your profiling is not great or that your tests aren't great, and so but you can find them when you have like your mental model and your hypothesis, and it makes it easier also to communicate with people about what's going wrong. And of course, now after I told you all about profiling and what the pitfalls are, of course you wonder how you could obtain a profile using common open source tools. And that's what I'm telling you about. I'm focusing here on async-profiler and JK Flight Recorder because they are the most common, and usually you shouldn't use Visual VM because it's not as accurate. So for async-profiler, you can just download it from GitHub. And what you do, it's just Java, it's just an agent. This time, not like with our self-written profiler, it's a native agent, so you have to download the suitable library for your platform. It only works on Linux probably. It has some basic support for Macs, but no support for Windows. JetBrains worked on support for Windows for IntelliJ, but it's not open source, so I'm not showing you here about it. So what you then tell async-profiler, hey, please start. So and then you can tell it which event it should listen to. So which to which time it should adhere. CPU time is like the actual time the process is running on your CPU. Then there's of course wall clock time, which is like the overall time, and this is important for like your intervals, because every 10 here you have like every 10 milliseconds of CPU time or wall clock times, or you can have other events like cache misses and so, which is pretty cool, because then you can really look into, hey, do I have too many branch misses, or should I like rewrite the code and be like a real proper performance engineer? And then you can tell like this, output a flame graph, and also please output a JFR file, like a JK flight recorder file, because it's like a a common standard out there in the Java profiling world, especially in the open source world. And you can even tell async-profiler, hey, please run JFR alongside because JFR has other advantages. So yeah, you can use it this way. And I wanted to embed async-profiler into libraries, so I needed a way to have a platform-independent jar that packages the different native libraries for all platforms. So I wrote the AP Loader project, and you can also like just directly run the AP Loader jar and tell it, hey, please profile this process, and you can download both from GitHub. And I can really recommend using async-profiler. It's a cool tool. If you want to learn more, I can recommend the async-profiler manual by use cases by Krzysztof Sluzarski, who wrote like a couple of dozen pages long document on this topic. I link in it on my last slide, and also on my talk page. And one of the cool features of async profiles is that it's embeddable, so especially via AP Loader. AP Loader is used by a few application performance monitors, and it's also hackable. So when I'm doing like my own research into profiles, I usually use a modified async profiler because it's just it's not too much C code and C++ code. Yeah, you should definitely take a look if you want to learn more about this. And then there's, of course, JDK Flight Recorder. It's built into the OpenJDK, which is quite neat because it works on all platforms, even the obscure ones, and it also works on Windows. But if we're honest, most of us are developing Java applications in the cloud running on Linux, so that's why async profile is still a good idea, because if you're not just running like desktop UI applications, then you probably be fine with async profiler. But you can, of course, run JK Flight Recorder, and to run it, you just start the flight recording and tell where to output the JFR file. It doesn't support directly printing JFR files, but Flamecross, but you have other tools for it. And then you have in older versions you have to enable the flight recorder, and you also have to add two options. That make it a bit more precise. They don't have a large performance impact, or they don't have any known performance impact. But yeah, async profile just automatically adds them to your JVM. And and then you can also use J-command to start and stop it. And yeah, it's already included somewhere. So the cool thing is you have many JFR events. So there are many events, not just method sampling stuff. You have over 100 events. There are so many events that it was like when I was developing a UI for it, like, hey, what are these events? And so I wrote a website. It's called Submachine, and you find it on submachine.io/JFI events. There you can see all the events, and also see in which configuration they're configured, so you can configure JFR differently, see all the properties, and also see in which JDKs they are available. And you can even write your own events. So consider now for a minute that we're working on the next big thing after software as a service. It's called math as a service. So we're developing our Fibonacci era, and it serves you the best and freshest Fibonacci numbers that ChatGPT can come up with in its algorithm. When you tell ChatGPT, please write the slowest Fibonacci number algorithm out there, and it's fine with that. But so essentially that's what our application does, to the profit of our customers. And so to create new JFR events, we can just extend the JDK.JFR event class, where here we just add two fields, and the dots are just for the constructor. It's nothing more in there. And then when we are in our server code, before calling the Fibonacci number functions, We're just creating our new session event, then we're telling it to begin. And then in the end, after we finish to commit, and so we have the session event with a stack trace, with a start time, with an end time, and then can see all these events in our UI and just carbon JFR UI. All of them support custom events. We can see, for example, that it took like 67 milliseconds to compute the 37th Fibonacci number. I told you it's not the fastest algorithm. And you can directly see it, and that's pretty cool because you can then have like logging information directly in context directly in your JFR file. And one thing, and also you can use, of course, other UIs. And one thing that I just found out recently, just like this week, is that Minecraft, the computer game, also supports to start and stop JFR recordings and to get JFR events. And they have custom events for like chunk generation. So if you fancy this, come to my blog next week where I wrote about this. But as you see, it's possible to inspect profiles here using the JK mission control, which is like the built-in one. That's like the official JK one. You get some information there, you get some flame graphs, you get some memory information, some garbage information, and that's all cool, but it felt a bit outdated, and the UI is it's Eclipse based. But so I wrote last year, started to write my own. It's the Java JAVAPRO profiler plugin for IntelliJ, like the first open source IntelliJ plugin, and what you can do with it. And so first open source profiling plugin for IntelliJ. So you can right click on a method, for example here main method, and tell it to profile with JVR or some profiler, get then your some information on the CPU load and on the heap size, and then the call tree. You can click around, see also in which specific lines I hit, how many times during profiling. Can get some flame graphs, then get some, and also some events, and that's pretty cool. You can try it out. It currently has some problems, so you can currently it might not work as expected. This is just an open source project, so I'm happy for people who want to help me do this. It's based on the Firefox profile as UI, and it's a small IntelliJ plugin on top of it. And you can use it also, of course, to just view JFR files, and that's where I use it most of the time. Of course, there's an impact of performance. Literature tells it that it's with JFR, with like the reduced setting, it's like between 0 and 2%. With async profile, it's more like between 0 and 4%, but usually it will depends on the application. It varies a lot. So please, before you do profiling, take a look, take a small application, take a small run, and check how much overhead you have with your setting. And then, of course, shortly, because I'm running out of time, the continuous profiling is the last thing. You can, of course, just tell us in profile, like, please repeatedly profile for 1 minute, store back to JFR file, that's all. You can also use different applications like Periscope that do this for you, and there's, of course, other tools like Parker too, that are continuously profiling your applications that help you. They, under the hood, like Periscope, use async-profiler and help you to monitor it and store it away. And to keep in mind, to finish it up, you should keep in mind that profiling is great for debugging. That profiling should belong to your toolbox, like debugging and testing. And please look into profiling tools before your manager at like 1 a.m. in the morning tells you, hey, our application is slow, please work on it. That's not the time where you should like get a grip with JMC. Just take your time beforehand. It takes a bit of time to learn profiling, but it's really worthwhile. And that was my talk here. I'm at Part-Time Nerd on Twitter. You can find all my open source contributions on GitHub. I write blog posts like currently once a week at mostlynodeless.de. And you find my team at Sweet Submachine and on Twitter and at submachine.io on the internet. And this QR code sends you to my talk page. You can also find it just by going to mostlynodeless.de, and there I have a lot of literature, I have a YouTube playlist and everything. So yeah, that's for me here. Thank you for your thank you for watching this. It's actually my last conference this year, and I'm quite happy to finish it with this cool conference here.